Hello again, and welcome back to part 2 of characteristics of quadratic functions. Let's go ahead and get started. So let's talk again about some of the characteristics of a quadratic equation, quadratic function. We know that parabolas are the names of the graph of a quadratic function, parabola. And they're either concave up or concave down, meaning they're open. Concave up means it's open at the top, concave down, open at the bottom. The axis of symmetry is a vertical line that divides the parabola into two congruent or equal halves. And each parabola has a vertex, and that's the point where the parabola crosses the axis of symmetry. It's right there in the middle. Okay, so we have parabola, some vocabulary, concave up, concave down, axis of symmetry, you should know congruent, and our vertex. So how do we find all these things, axis of symmetry and vertex and things like that? Well, we use the coefficients, the a, the b, and the c of our quadratic function to find the axis of symmetry and our vertex. So the first thing we notice about a quadratic function is we can tell if it's concave up or concave down based on the sign of the coefficient a. So if the value of a coefficient a is greater than 0, the parabola is concave up. And remember, if it's 0, then we no longer have a quadratic function. So if it's greater than 0, we're concave up. If it's less than 0, we're concave down. Remember, even x squared has a coefficient is 1. And the opposite of x squared, the coefficient is -1. So we have concave up and we have concave down. We know that because of the sign of the coefficient a. So really quickly, let's see, use the sign of the coefficient a to determine if the parabola of these functions would be concave up or concave down. Okay, this one would be up because our a is a +2. This one would be concave down because our a, is equal to -1. This would be concave up because our a is equal to 12, and this would be concave down because the value of a is equal to -1. So that's one of the first characteristics you can pick up on a quadratic function, is whether or not it's concave up or concave down, just by looking at the the coefficient on the variable x squared. All right, so what about the axis of symmetry? Well, you can use another formula, or a formula, x equals the opposite of b divided by 2 times a. Now remember, axis of symmetry is just where the where we split the parabola. So it's just the value of x where that occurs. It's not actually a point, it's just the value of x where that occurs. So the formula we use is the opposite of b divided by 2 times a. Again, the ABCs of quadratic functions. Let's go ahead and apply this. So let's calculate the axis of symmetry for the quadratic function y equals 3 times x squared minus 6 times x plus 1. Remember, that's my a, that's my b, and that's my c. So I'm going to write the formula down. Then I'm going to substitute. B is -6, a is 3. So I have -6 divided by -6, which is 1. So that means that my axis of symmetry for the graph of this particular function is going to be at -x equals 1. So where x equals 1 is where it crosses. That's all I know by doing that. But I do know a is concave up and my axis of symmetry is x equals 1. So that's two characteristics right off the top. So let's practice a little bit. Let's see if you can determine if the parabola is concave up, concave down, and calculate the axis of symmetry. Okay, so the first one is concave down because our coefficient a is less than 0. And our axis of symmetry for the first one is x equals the opposite of b divided by 2a. Our b is negative 8. Remember to always take that negative sign with you. And our a is negative 2. So our axis of symmetry is x equals negative 2. And we're concave up on number 2 because our coefficient a in this case is equal to 1. And to calculate our axis of symmetry, we get 1. Okay, so that's two characteristics, whether it's concave up, concave down, and what's the axis of symmetry. Okay, we're going to go over vertex really quickly, and then we're going to finish up in the next video. So the vertex, what we do is we take the axis of symmetry and just plug that number into the function. So we already did this. We know the axis of symmetry is 1. So we want to find the vertex. We just take that number 1 and plug it in or substitute it into our function. Or more technically, we evaluate. So we have y equals 3 times the number x squared minus 6 plus 1 is equal, and we're going to say that x equals to 1, our axis of symmetry. We're going to evaluate. So we get 3 times 1 squared minus 6 times 1 plus 1. That's 3 minus 6 plus 1, which is not right. 3 minus negative 6 is negative 3, plus 1 is negative 2. So that should be negative 2. So our vertex is 1, negative 2. Our axis of symmetry is just 1. Okay, so we're going to stop right there. We've talked about 3 characteristics: concave up, concave down, axis of symmetry, and vertex, and we'll wrap it up in the next video.